Danny Marfatia from University of Hawaii is a role expert in quantum theory, particle physics, phenomenology.
Sure.
And you gave a talk on non-standard interactions in relation to neutrinos.
That's right.
But I would like to ask you a question about, in a more wide sense. Why nowadays non-standard interactions is on the market? Why are we speaking about this?
Sure.
Yeah, and what can be said for sure as a solid base about these non-standard interactions?
Well, neutrino physics has been growing a lot in the last 2 decades, but we still don't have a complete understanding of neutrinos. And since neutrinos are so weakly interacting, it is one potential area where there could be new physics, but which is very difficult to find. I mean, which has been difficult to find, but which could appear in neutrinos. And so, given the interest in these large experiments that are being built, one of the possibilities is that you might use these large experiments to actually find new physics using neutrinos. So that's why non-standard neutrino interactions has become so popular, because it is an avenue where these billion-dollar experiments might be one of the places to find these new physics signals. Yeah.
And well, it is known that the idea is to use more or less complete experimental data to constrain the parameters.
That's right.
Through which the non-standard interaction appears. Yeah?
Right.
And from different experiments, from solar neutrinos, from supernova, from terrestrial neutrinos, we have different constraints.
That's right.
And the gap between different values of these constraints are huge.
That's right.
What do you say about this?
Well, I think you have to be careful in how you interpret all these constraints. Make very strong assumptions that only one such parameter is non-zero while all the others are zero, and so on and so forth. So there are some analyses where they kind of try to fold all of this together, and those are, I would say, more credible than some of the constraints that come from just, assuming that only one parameter is non-zero. So it's complicated.
And also, of course, another issue is just if once this will be checked or confirmed, the idea is what it is, because it's like a phenomenological generalization of theory.
That's right. That's right.
Some quantum fields should be underground theory should be developed.
That's right. But I think the trouble is that since we don't really understand neutrino masses themselves, it's hard, to consider a solid framework in which to look for non-standard interactions. Yeah.
The first question is what is neutrino mass, as we have heard from
exactly.
Professor Billington today.
Sure, exactly.
And then all these other very important issues will be solved.
Need to be sorted out. Yeah.
Well,
exactly.
thank you.